When you learn about statistics, everyone is talking about p-values and hypothesis testing and statistical significance, and that is really important. That's a major goal of statistics. But it's important to realize that statistical significance is not the only kind of significance. In fact, we have multiple different significances, and they're not the same as statistical significance, which is given to us by the p-value. So we have statistical significance. This you've already learned about. It's the probability of observing data the way you observed it if the null hypothesis were really true. So that is statistical significance. But there's also another kind of significance called theoretical significance, and that means that a finding is relevant for a particular theory, or the finding leads to new experiments, and this has nothing to do with statistical significance. You can have statistically non-significant results that are actually very important for a theory. And there's also clinical significance, and this list could go on and on. We could talk about practical significance, educational significance, and this is whether a finding is relevant for, in the case of clinical significance, diagnosing or treating a disease, or maybe making people healthier. Again, that is a separate significance from statistical significance. So I'm going to walk through a few examples just to make sure that this point is really clear. So let's imagine we have a hypothesis and a result from some scientific research. So here's one. The MMR vaccine, this is measles, mumps, and rubella vaccine, causes autism. Now, I'm making up this number here, but the general finding is true, that the p-value is very large. So I'm saying 0.79, and this is a p-value that's very close to 1, which means that we cannot reject the null hypothesis, which means that MMR vaccine does not cause autism. So here we have no statistical significance. This is a really strongly non-significant effect, but that has very important clinical and societal significance. Here's another example. So our hypothesis is that piles of sand with larger grains collapse sooner. And that has a really, really tiny p-value, 0.001. Again, I'm making up this number, but it is true. People have done research into this. It is true that piles of sand with larger grains collapse sooner. Now, here we have a very strong statistical significance. There's also a strong theoretical significance, and that's because there is a theory in physics about the dynamics of interactions across a lot of things. And it's variously called scale-free or fractal or self-organized criticality. So in fact, this finding is important for physical theories about the organization of our universe and the physical laws that govern our universe. On the other hand, it's kind of hard to imagine how piles of sand that are collapsing sooner because they're made with bigger grains. It's hard for me to imagine how that has a direct clinical benefit or societal significance. So that's just a few different examples, and the main point is that it's important to keep in mind that although statistical significance is the main goal of statistics and statistical modeling, whether a finding is statistically significant is a separate issue from whether it is theoretically significant or clinically or societally significant.